Good day, grade 12s. Welcome to our technical maths. Today's lesson is going to be on functions. I hope you are well and you are still engaging to your books. And then please make sure that you practice enough under technical mathematics. Prepare yourself for the incoming trial exam and the final examination. As I was saying, that our topic today is going to be functions, and then you remember functions is one of the topic that you'll get in paper 1, right? Now let's get into function and understand what you're going to be dealing with today. Now under content, I've tried to outline this topic of functions, and then you can see from on the screen that this topic contributes 35 plus or minus 3 marks for paper 1. It's very important topic. And then under functions, we are going to be talking about linear functions, quadratic functions, hyperbolic functions, exponential functions. But remember, for technical mathematics, we also have to include a second, right? There is a function that called second. It's going to be part of this lesson for today. Then let's proceed. Now, under functions, as we have said that we're going to be dealing with these different types of graphs. The first one you can see, let me just show you with my pen. The first one is a linear function. You can see this is the equation of linear function, and we're referring to this graph. This is the straight line graph. And then this one is what is the parabola equation. And then the graph that we are referring is this one, is the parabola. So you can see that parabola is being given in terms of different ways. You can see the first one is this one of ax squared plus bx plus c. Another form, it is this one of a into x plus p all squared plus q, right? And then we have this one, which is what? Exponential, right? So the exponential is this graph here. You can see this is the exponential graph, right? And then the last, the second from the last, which is the hyperbolic function, which is this one here, hyperbolic, which is this one. And the last one is the equation of a second, right? It's the equation of a second. Then it's very important to understand this parametric, which is A, Q, and then P and Q as well. And then here is A, B, and Q. So it's very important to understand those parameters on how does those parameters affect our graphs, right? Then we'll be learning more into those different types of parameters, right? And then let's proceed and see what we're having. Now, I'm going to be giving you the example of parabola graph, what things you should remember or you should know as a learner. For instance, let us start to having what? The Mara graph of parabola graph. That's where you have started when you dealt with functions. And then it says a learner should be able to determine. These are the things that you need to know when you are dealing with parabola graph. It's very important. The first one, you must be able to determine the domain and the range of the graph. The second one, you must be able also to determine the X and Y intercept and to determine the maximum or the minimum value and turning point, and the last one, equation of X of symmetry. So every time when you are dealing with parabola, make sure that you address all these 5 important points, right? Now we are going to be starting with the first one. Try to answer it based on the graph that we're having here. You can see this is the original graph, right? Let us start with the original graph, and so that by the time we get other graphs of parabola, which they are not original graphs, then we should be able to answer them, right? Now, let's see on how do we determine the domain and the range of the graph. Now you can see from the scenario, from the solution per se, from the solution, they say domain is the X is the element of all real numbers, right? Now, my dear learners, once you come across a parabola graph and then you are being asked to determine the domain, you must always remember that the domain of the parabola graph, it will never change. It will always be X is the element of all real numbers, right? You can see from the graph here, normally this graph, it continues, it must have what arrows there so that it shows that this graph is still continue. You can see this graph is continue to the X values. You can see, remember domain, we are referring to the values of X, right? So you can see this graph is still continue. And then when it continue this side, and then now we are going in this direction, right? So the graph is going to negative infinity, and also this side is going in this direction, is going to positive infinity, right? You can also write your domain in that manner by saying X is the element of negative infinity to positive infinity. Or you can just put it in this way of saying X is the element of all real numbers, right? So the domain of parabola graph, it will always be X is the element of all real numbers. But now let us look into range. In this case, say range, so Y is the element of 0 to positive infinity. Now, when we're talking about range, we are referring to Y values, right? Y values, meaning you only have to focus on this Y axis, this Y line, this Y axis line together with the graph. You can see the graph starts here where it cuts Y axis at 0, and then it goes to positive infinity, you understand? So it starts from 0 to positive infinity, right? And then for us to be able to calculate the range, we need to know the value of Y on the turning point, because that value of Y on the turning point is where the graph starts of the parabola, right? So it's very important to know the value of Y on the turning point. Is very clear from this graph that we are working on. The turning point is 0 is to 0, and then the value of Y on that turning point is 0. Then hence we are having what? 0 is to positive infinity, right? Then go to number 3, it says maximum or minimum value. Now, it's either the graph gives us maximum value or it gives us minimum value. But when will the graph give us a maximum value? If the graph faces down like this one, right? Let's say we have a graph facing downwards like this. This graph is going to give us maximum. The point, the turning point there is going to give us what? The maximum. And the graph is facing up, then it's going to give us what? Minimum. So it's very clear from this graph here. This graph is going to give us what? It's going to give us minimum, right? And then when we talk about minimum value or the maximum value, we normally refer to the value of a Y on the turning point, right? And then let's see. Remember, we also talked about the Y-intercept, X-intercept. Then it's X equals to 0 and Y equals to 0. You can see the graph cuts X at 0, Y 0 there. And then as for number 3, the minimum value there, we said is 0. Then where do we really get this value? We go straight to the turning point there, and then we are looking for the Y value on the turning point. And then that value is our minimum value, right? All right, now we can go to the turning point. How do we determine the turning point? It's very clear from this graph that we are having. Our turning point is 0 is to 0 there. Turning point is 0 is to 0. It's very simple. The last one, equation of X of symmetry, X equals to 0. Remember, X of symmetry is this line which it cuts the parabola graph into 2 equal parts. Yeah? So that line normally, we normally see that line with a broken line. So it lies on this line, which is y-axis. So we cannot be able to see it, right? We can see it lies on this one. So then every time when you are being asked to determine the equation of X of symmetry, just go straight to the turning point. To make it simple, just go to the turning point, because that line, because this line is passing through a turning point. So you just take the X value there on the turning point. Then it will help you to determine the equation of what? Of X of symmetry. All right. And then that's all for parabola graph. Then let's proceed. Example of hyperbolic function, hyperbola. Let's see. A learner should be able to determine the domain and the range as well, X and Y-intercept, equation of asymptote. Now we are going to be dealing with asymptotes, equation of X of symmetry, all right? So this is the original graph of what? The original graph of a hyperbolic function, right? Is this one. You can see we have the two curves there, the one on the first quadrant and the other one is on the third quadrant. Okay. Now let's see on how do we determine the domain and the range of this particular graph. All right, it say the domain is element of all real numbers, but X should not be equals to 0. So always when you are determining the domain, you will always have what? This restriction, right? This restriction. And it says it will always be X is the element of all real numbers, but restriction, we'll also have to see what is our restriction there. Because you can see that if X becomes 0 there, what is going to happen? It's going to be undefined, because 2 divided by 0 is undefined. So we avoiding to get undefined, right? So X must not be equals to that when we want to solve for the value of Y. You understand? And then the second one, my dear learners, we have to determine the range, and the range is Y is the element of all real numbers. It will always be like this as well, but restriction here in this case is Y is not equals to what? 0, right? Because look at, if you substitute 0 where you see Y, then you have to solve X, then you will have to cross multiply, and once you cross multiply, this X is going to be multiplied by this 0, then X is going to disappear, right? Because any number you multiply by 0 is 0, right? So that is the domain and the range for you. And then let's proceed. X and Y-intercept. You can see that no X-intercept and Y-intercept. It's very clear from this graph. This graph, and as well as this one, does not touch or pass through this X-axis. Also does not pass or touch this Y-axis, meaning we don't have X-intercept and Y-intercept in this case, right? Because these two lines, they will act as what? As asymptotes, right? And then let's go number 3 and understand the issue around the asymptotes. Now, the first asymptote is X equals to 0, meaning the first equation of asymptote is X equals to 0. Where is that? Remember, when you talk about the first asymptote of where X equals to 0 is this line here, right? This line. And then we normally see the asymptote lines with broken lines, but because it is on this line of Y-axis, we cannot be able to see it, but it's this one. And how will you be able to see the asymptote? Is a line where the graph approaches. You can see this line or this graph approach this line here. So this line is going to act as what? As asymptote. The same applies on this side. You can see the graph does not touch, it's just approaching. Also this side, this graph is approaching this line of X-axis as well as this side as well on the right hand side. You can see. So hence I'm saying the Y-axis and the X-axis, they will act as what? As asymptotes. That's why X equals to 0 and the other one is y equals to 0. So those are equations of asymptotes. Okay. The last one, which is the equation of X of symmetry. Equation of X of symmetry. Now, remember earlier on we talked about X of symmetry when we were dealing with parabola. Now we also have this one on hyperbolic function. And then the first one is say y equals to x. We all know that if we had to plot that line, it's going to pass through this point here. So it's going to pass through here. So this is going to be y equals to what? Y equals to x. Let me try to write x there. And then the other one, y equals to negative x. So it's going to come in this. Sorry, let me just try to write a straight line that will pass here. And then this one is for what? This one is for y equals to negative x. So we do also have X of symmetry when we are under hyperbolic function. Okay, that is that for hyperbolic function. Then we can proceed. Exponential function, let's see. Under exponential function, a learner must be able to determine the domain and the range as well, X and Y-intercept, equation of asymptote. Now listen to the third one, it's an equation of asymptote, because for exponential, we are dealing with one asymptote, unlike hyperbolic where we are having two asymptotes, right? So please don't confuse that. Then let's see on how do we determine the domain and the range for this exponential graph. Then the domain, it says x is the element of all real numbers. The same with parabola. The domain for parabola, the domain for exponential, it will never change. It's always x is the element of all real numbers for exponential function. And then as for range, range is y is the element of 0 to positive infinity. Now, for you to be able to determine range, you need to know what is our asymptote. What is the equation of asymptote? Because now for exponential, we only talk about one asymptote, which is moving horizontal. And then I said clearly earlier on under hyperbolic that a line which is being approached by a graph is going to act as what? As asymptote. It's very clear this x-axis here is what? Is going to act as what? As asymptote, because this graph of exponential is approaching it. You can see the graph is approaching it, but it will never pass through this line or touch this line, right? Because the graph does not define there. Okay, so then since the asymptote that we're looking for is moving horizontal, and then it's very clear that it's going to cut the y-axis at 0 there, right? Then look at the range now. It says 0 to positive infinity, meaning the graph starts with 0 to positive infinity. You can see that the graph is moving to positive infinity, because remember for range we are referring to y values. You can see the graph does not pass this line of axis. It only approaches it, but on this side you can see the graph is still continue up to positive infinity there. And then you can see that for this 0 we did not put what, and then we can see that this exponential graph does not start at 0. It's only approaching 0 there. So meaning the square bracket means this 0 is not part, because the graph does not start at 0. Maybe 0, something up there. but it's not 0. So 0 is not included, right? So it meaning we depend on the asymptote when we have to determine the range. Because if you don't have asymptote, there's no way you can be able to determine the range. Okay. Now let's proceed. I hope you do understand. Number 2, X and Y intercept. No X intercept is very clear from the graph that we're having. Let me just remove this. Let me erase this one and this one. All right. Now, from the graph that we're having, you can see this graph is just approaching the x-axis. It does not touch. So meaning we cannot say that we are having x-intercept, right? Even if you can determine the x-intercept. Remember, when you had to determine the x-intercept, you have to let y equals to 0. Now, if y is 0 and then equals to what? 2 to the power what? To the power x. Can you be able to solve for x? No, you cannot. Because why? We don't have x-intercept. So it's not possible to get the x-intercept on this case, okay? Then as for y-intercept, yes, you can be able to do that. Remember, when you are in need of y-intercept, then you just let x to be 0. If you put 0 where you see x, then 2 to the power 0 is 1. Then you can see from this graph that this graph of exponential pass this y-axis at 1, right? So that's how you should determine the x and y intercept. And the last one, equation of asymptote. Remember, as it also indicated that for exponential, we are dealing with one asymptote, and that asymptote is moving horizontal, and then which is going to be this line of x axis, right? But normally, when we show the asymptote, we normally use the broken lines. It's going to be a line with broken points there. Then, but in this case, it's not going to be possible to see that because it's just lying on this x-axis there. Now, where this line cuts y-axis, it's going to be, it cuts y-axis at 0. Hence, the equation of asymptote is y equals to 0. And that is that for exponential function. Exponential function. All right. Then let's proceed. Example of a circle. Now we have a circle now. Let's see under circle what we're having. All right. We have equation of a circle, y equals to plus or minus square root of 1 plus r squared. Remember the standard equation. It says y equals to plus or minus square root of r squared plus x squared. Learner must be able to determine the domain and the range and the radius of the circle. Let's see how do we determine that. The domain, remember the domain we are referring to y values. We have to check where the graph starts and where the graph ends. You can see it's negative what? X is the element of -1 to +1. The graph starts here at -1 and then ends the domain. You have to determine the domain and the range for circle, and then radius of the circle. You can see that r squared equals to 1 there. Remember, I also indicated when we are dealing with the standard equation of a circle is y equals to plus or minus square root of r squared. Now, instead of r squared, you can see it's 1 there. So r squared equals to 1. Then when you have to solve for the radius, you just square both sides. You square both sides, then the answer is going to be what? It's going to be +1. So our radius in this case is +1, right? Let's proceed. A concept to master in function. These are very important, boys and girls, when we're dealing with functions. One, understand the effect of parameters. For instance, y equals to bx plus, you must understand b. How does b affect the graph? How does q affect the graph? The same applies with the hyperbolic function a and q. What is happening there? How does a and q affect the hyperbola graph? And then the last one, parabola graph, a, p, and q, right? It's very, very important. Now, the concept that you should master on function, you must be able to sketch the graph, and then you must be able to find the x and y-intercept, the turning point for parabola, asymptotes. Remember, graphs that are dealing with asymptotes, we are having exponential, we are having hyperbolic function. And then find the equation of the function if the sketch is given, right? If we are having a sketch, you must be able to determine the equation of that particular graph. Understanding the concept of asymptotes and X of symmetry. We know earlier on we spoke about asymptotes. We also touched around the X of symmetry, right? When we talk about asymptote, you must know which functions that have asymptotes, and then which functions also have what? X of symmetry. So it's very important. And you must be able to determine the domain and the range, and you must also interpret the graph. It's very important, right? Now let's proceed. Let us get one example of function. Let's see. The graph below represents h of x equals to negative x squared, negative 3x plus 1, and g of x equals to negative mx plus 10. The two graphs intersect at point A and C. You can see the two graphs, point A there and point C there. And the points are A and B and C are intercept with the x of h. D is the turning point of h. Determine the following: the coordinates of A and B. The coordinates of A and B. A and B. It's very clear from this graph that A is what? A is the x-intercept of parabola graph and as well as straight line. B is x-intercept of parabola graph, right? Now, in order for us to get this coordinate of A and B, then we'll have to use the equation of parabola there, because we have an equation. We cannot be able to use what? The straight line, because you can see that we are not having the value of m in that case. So now let's see on how do we determine that. Now remember, when we are calculating for x-intercept, you let y equals to 0, right? Then you just put 0 where you see y. Remember, h of x is the same as y. So just change the sign. You can see that. Let's change the sign: positive, negative, negative, positive. Now we can be able to factorize this. Do you have factors? Yes. It's x plus 5, x minus 2. Then the value of x equals to 5 or equals to 2. Now remember, we are calculating for coordinates. Now the coordinate of A is negative 5 is to 0 and positive 2 is to 0. So we are done answering that question. And the second one is the coordinate of C. Coordinate of C, let's go. and coordinates of C, you can see that is the y-intercept of parabola graph and straight line graph. But we cannot be able to use the straight line graph. Why? Because this we are still having what? The equation which is incomplete, because we don't know what is the value of m there. Then it's very clear that we're going to use the parabola graph, and then if you need y-intercept, you let x to be 0, then you just put 0 where you see x, then the answer is going to be 10. But remember, we in need of coordinates. The coordinate is 0 is to 10. Second question, on the third one, actually, the coordinate of the turning point. Now, let's see on how do we calculate the turning point. Now, you are going to use this formula to calculate the value of x on the turning point, which is x equals to negative b over 2a. Then we are using this formula to calculate what? To calculate x, the value of x on the turning point, right? In this case, we can see is 3 over minus 2. So that is the value of what? Of x on the turning point. Now we are now looking for the y corresponding value for turning point. Then we're just going to take this value, the value of x to what? To the original equation. Then where we see x, then we're going to substitute the negative 3 over 2. Then our value of y in this case we can see is 49 over 4. So these are the coordinates of turning point. All right. Then let's proceed. Then we are on example 2. Example 2, functions. We're still having the same scenario, the same graph, but now we have another question that says the value of m. The value of m, where is m? You can see is this straight line graph. We have to determine the value of what? M, right? Now, for you to be able to determine the value of m for this straight line graph or linear graph, then we are going to be looking for any point on this line, right? Now, remember, we have determined the point A. We have also determined the point C, because those points, they are also on what? On this line, on this straight line, right? So you're going to choose any point. You can take point A or you can take point C to determine the value of m. Then it's not a problem. Then let's see how do we do that. And then you can see from this one, we have taken the point A, where y is 0 and then x is -5. And then you just transpose this 10, this side is going to be negative. Then you're going to divide both sides with 5. Then the answer of that m is -2, right? It's -2. Then the second question, determine the values of x for which f of x, you can see, no, h of x actually. H of x is the parabola graph. You can see the parabola graph. Multiply by g of x is the straight line graph. Is less than 0. Now let us see on how do we answer that question. Now the answer for that is x is greater 2. Then let's try to understand how did they determine that answer. Then remember, h of x is the same as y, and then also g of x is the same as y. Okay, so we want where we multiply the two functions, and then you get what? You get a negative value, which is going to be less than 0, because any value which is less than 0, it must be negative, right? Now let's come to this one. Then we all know that y is negative below the x-axis, right? Remember, y is negative there, meaning this graph of parabola is negative, 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 negative below the x-axis. The same applies with this straight line. Is negative, 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 right? Now, if you multiply this negative of straight line together with negative of parabola. What are you going to get? You are going to get positive. Then positive cannot be less than 0, right? Meaning this is not going to give us solution. Then just here above this x-axis, we know the graph now start to be positive, positive. The same applies with the straight line. Is positive, positive, is positive there. Let me, is positive, right? Here is also positive. Above the x-axis, any graph is positive, and then also here is positive, right? And then just after this B here, below the x-axis, the graph starts to be negative, 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 negative. Now, for us to be able to solve this question, it's either this h of x becomes negative, multiply by, and this graph of G must be positive, or this h of x must be positive, and then this G of x must be negative. That's where we're going to get our solution. Then we can see this one is negative, negative, positive, 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 and then positive, positive. But let us look at this point B. Let me just draw a line passing through B. And then you can see that from this point B and going to the right, and to the right, this graph is positive there, up there is positive, and then our graph of parabola is negative, right? Meaning that's where we're going to get a value which is less than 0 there. Then what is the value of B? Remember, we've determined the coordinate of B. It was 2:0, right? It was 2:0, meaning from 2, if we take this direction, because that's where we're going to get our solution there, because this is going to be negative, and then up there is going to be positive, right? Then from 2, if we go to the right hand side, are those numbers greater or less than positive 2? They are greater, and those numbers, they are represented by x. You can see from this solution, x is greater 2, meaning all those numbers which are greater 2, they are giving us this solution to be true, right? Where that negative value is less than 0. So that's how you should answer this question. And then let's proceed. Example 3. The graph defined by this, it's very clear that this graph is what is hyperbolic function of hyperbola is drawn below. You can see this is the hyperbola graph. The graph cuts x-axis at -2. Here is x-axis. The first question, they determine the numerical value of q. We're in need of this q, right? Let's see on how do we answer that. Q equals to 2, right? Now, Q, it will always act as what? As the horizontal asymptote. Remember, hyperbola has 2 asymptotes. The one that is going horizontally, the one which is vertical. Then Q is what? Is the horizontal asymptote. And then it's very clear from the graph, the horizontal asymptote, it cuts y-axis at 2. So the answer is 2. Q is 2 there. And numerical value for A, for you to be able to determine the value of A, then we have to have a point on these 2 curves, right? Then that point that we're having in this case, you can see is -2:0. Then we're going to use that point to determine the value of A. Meaning, if we don't have any point on those 2 curves, there's no way we can be able to determine the value of A. But as for Q, is very simple. You just have to look for what? Horizontal asymptote. It will always be what? Your Q. And then as we have said that we're going to use this point -2:0, and then y is 0 there, x is -2, then we can just solve the value of a. Then we're going to transpose this positive 2 onto the left-hand side first, and therefore you're going to cross multiply. Then when you cross multiply, the value of a equals to 4. The equations of asymptote of f. The equation of asymptotes, remember, hyperbolic has 2 asymptotes, right? Then let's determine the equation. The first one is x equals to 0, is the vertical one. You can see the vertical one, it cuts x at 0 there. That is the vertical asymptote. The horizontal asymptote is y equals to 0. You can see this one, it's cut y at 0, I mean at 2, right? So that's how you should determine the equation of asymptote. Now the domain. Let's see the domain. Remember the domain, I make it very clear that it will always be x is the element of all real numbers, but restriction says x should not be equals to 0. Because if you substitute 0 there, here, at x, where you see x, then it's going to give us undefined. Okay? So that is the hyperbolic function. Example 4. Give the function defined by this graph, and then this one, and then it says, is the graph on increasing or decreasing function? Is the graph of G, which is this graph, an increasing or decreasing function? Let's see on how do we call that. The answer is decreasing. Now, how do we know or determine the increasing, decreasing? Now we can see here the standard equation. Remember, it has b to the power of x plus q, right? Now, if b is greater 1, then the graph is going to be increasing function. If b is greater 1, then the graph it will always increase. Now, if b is between 0 and 1, if b is between 0 and 1, then the graph it will always be decreasing. Hence, the answer for this is decreasing, because you can see 1/2 is between 0 and 1. Then the graph it is going to increase. I mean decrease, right? It's going to decrease if b is between 0 and 1. Write down the equation of asymptote. Let's see. The answer is y equals to -4. Earlier on, remember, we also touched that this exponential graph. Remember, this q is always what? Your horizontal asymptote. Is horizontal asymptote. And then in this case, you can see that -4 is our horizontal asymptote. So the equation is y equals to -4. Please, my dear learners, don't only write -4, because if you write -4, you did not answer the question. The question says determine the equation. So the equation must have equal sign. Then you have determined that asymptote, the equation of asymptote. So it's y equals to -4. 3, determine the x and y intercept. If you want x intercept, you let y to be 0 there. You just put 0. And then the third step, you transpose -4 to the left-hand side. And then you just apply the law of exponent there. You can see we have to make our base to be the same so that we can be able to equate the exponent there. So it's -x equals to 2. Then the answer is -2. And then that is the x-intercept. For us to get the y-intercept, you let x to be 0. And then where you see x, you just put 0 there, and the answer is going to be -3. And the domain, I said the domain for exponential, it will never change. It will always be x is the element of all real numbers. All right. Example 5. All right. Given the function which is f of x equals to 2 to the power x minus 1, you can see this exponential graph. Sketch the graph of f of x and clearly show all the intercept with the x's and this. Now we have to sketch the graph. Let's see on how do we sketch the graph. So this is the answer. We have to sketch the graph. You can see that horizontal asymptote is -1. So we just make the broken lines. You can see our asymptote line is this one, and then y and x intercept is 0. So this is going to be the curve for exponential graph, right? This is the curve. And then number 2, determine the domain and the range. The domain, I've made it very clear, it does not change. But as for range, I said the range depends on what? On the horizontal asymptote, right? Then is y is the element of -1 to positive infinity. You can see the graph starts at negative, not necessarily start at -1, because you can see this graph just approach the asymptote, right? But we're going to say -1 to positive infinity. You can see the graph is moving to positive infinity there, right? And then it's very clear. Even the type of bracket we used is round bracket, meaning that -1 is not part of the solution, it's not included, right? So that's how you should determine the range. You have to know the asymptote. The last question, write down a new equation of g of x if the graph of f of x move upwards with 5 units. Let's see. So we just had +5 was going up. So it's going to affect this q here, this -1. So the answer, you say -1 + 5, it gives us +4. So this is going to be our new equation of g of x. Example 6. Consider the graph g of x equals to this. Write down the domain and the range. Domain and range, and this you can see is parabola graph. And we talked about the domain and the range earlier on. Then we said that the range, the domain, it will always be x is the element of all real numbers. It does not change, my dear learners. Don't forget that. And then for range, remember for range, it depends on what? On the turning point. And then on the turning point, we are looking for the y value there. We are looking for the y value. So the turning point for this this particular parabola graph is 4. Let me try. Is 4 is to negative what? -18. This is the turning point, right? Now look at the range now. Look at the range. Is y is the element of -18 to positive infinity. Can you see this -18? You can see we have used it. So it's very important that you know the turning point, the value of y on the turning point. Then you can be able to determine the range. Write down the turning point. Let's see. The turning point, as I said, that is 4 is to -18. That is the turning point. You can see that you don't have to calculate the turning point if you are giving in this form. If the parabola is given in this form. Remember, we earlier on we had example where we had to calculate the turning point, and then it was in the form of ax² + bx + c. Then we had to use the formula to get the value of x first on the turning point, which was x equals to -b over 2a. But if it is in this form, you just have to take. You don't have to calculate. You take. You can see this -4. If you take it to the point, it's going to be +4. And then as for -18, you take it as it is, and then it's going to be act as y on the turning point, which is -18. So that's how you should determine the turning point of the parabola graph. And the last question, write down the equation of X symmetry of G. Let's see. we set is x is equals to 4. What you can do, you can take this x minus 4 always. Every time when they ask you the equation of a x of symmetry, you take what is inside the bracket. In this case, you can see is x minus 4, x minus 4. Then you solve for x. Then x is going to be what? It's going to be x equals to 4. And then I also indicated that if you are looking for equation of x of symmetry, you just go straight to a turning point and you take the value of x on the turning point. Then it's going to give you what? The equation of x of symmetry. And then we're going to say x equals to 4. And please don't just write 4 when you have to answer this question where it says determine the equation of x of symmetry. Equation must have equal sign. So x equals to 4 is going to be our equation of x of symmetry. Example 7, under circle. In the diagram drawn below, the semicircle is a semicircle, which is this equation, the standard equation per se, and the tangent to a semicircle at this point, the tangent there. Determine the equation of a semicircle. Determine the equation of a semicircle. Now, for us to be able to determine the equation of a semicircle, we just only need the r squared, the radius, r squared, the value of r squared. Once we have that, then we'll have determined the equation of that particular semicircle. Let's see on how do we do that. Now, because we don't have r squared, then we have to look for a point on the semicircle there, on the semicircle. Which point? Then we can see we're having one point, which is point P. Then we're going to utilize that point to determine what? To determine r squared, because this point is x and y. Then let's see, then where we see x, we put -3. Where we see y, we put -3. Then we try to solve that. Then we divide with negatives both sides. Then after reaching this stage, because now we are in need of this r squared, and then this r squared is inside the square root. To get rid of this square root, remember you square both sides. Let's square both sides so that you can remove the square root. And then now we are having r squared minus 9 equals to 9. Then we're going to transpose that 9 that side, which is positive 18, because now we are calling for, all right, now we have determined what? R squared, because we want r squared. We don't want r, but we want r squared. So in this case, we can see that r squared is 18. Then we just put 18 there. Then this is going to be what? This is the equation of the semicircle of H. The second question, equation of the tangent. Equation of the tangent to a circle. Now remember, you can see that tangent is the same, it's a straight line, right? And for us to determine the equation of a straight line, we need a point and a gradient. We need a point and a gradient. And let's see on how can we determine the gradient. We can, because as for point, you can see we're having that point, which is point P. But the problem now is what? Is to get the gradient, or how do we get the gradient now? We said that the gradient of OP, where O is there, OP, if you draw a line there, and that will meet the tangent, you can see the gradient of OP multiplied by the gradient of tangent equals -1. Why -1? Because this line from O to P is perpendicular to the tangent, meaning you know that when you are dealing with two lines which are perpendicular to each other, then this how you are going to determine what? The tangent, right? Then let's see. Now, because we are having the coordinate of point O, which is 0:0, you can see this is 0:0. We also have the coordinate of P, then we can now determine the gradient of what? Of this line OP, because we've got 2 points. Remember, if we calculate the gradient, we only need 2 points. You can see here, we are trying to determine that. And then this is that. And then Now you can see it's going to give us negative, actually it's going to give us +1, and then multiply by a gradient of a tangent, and then the answer is this one. Now the gradient of a tangent is -1. We are having a gradient, we are having a point. We can now calculate the equation of a straight line. Okay. All right, this is the equation of a straight line, and then you just substitute the point. And then that is the answer. The equation is y equals to -x minus 6, right? And then example 8. Example 8, circle. Let's see. All right. The graph of a semicircle defined by this, you can see now we're having the equation is centered at the origin, and the exponential let's see on how do we determine that. First, we need to determine the radius, because we know from this center to any point on this circumference of a circle is what? Is the radius, is the distance. Can you see that is the distance there? So if we just get the distance from O to B there, then it's going to give us the coordinates. All right, you can see that from the coordinate of A is -2 is to 0, and then B is 2 is to 0. And then number 2, the numerical value of Q, which is this one, the horizontal asymptote. Let's see. Then we are going to take any point on the graph, which is this one is 0 is to 2. We cannot take this one of C because we don't have the value of K, right? We can only use this one of 0 to 2 to determine Q. Then our value of Q equals to 1, all right? The value of X for which the G of X is less than H of X. Let's see the answer. So that is it. It's going to be our answer. Then how do we answer this question? Then G of X is less than H of X. And then for G of X to be less H of X, this graph of G of X, it must be below the graph of H of X. Now let us look. We can see that the graph of G of X is below this one of H of X from this point until this point, right? That's where the graph of G of X is less than H of X. Then we have to determine the value of X. You can see the value of X on this point is -73/50. And then at this point, X is what? Is 0. Then hence we're having this. So it ranges from this one and to this one, right? So as X is greater this and X is less than that. That's where the graph of G of X is less than H of X. Now the range of G, let's see the range. Now the range is say Y is the element of 1 is to positive infinity. You remember the range for exponential graph, it depends on the what? On asymptote, right? On asymptote, we can see that we have, remember we have determined the value of Q, and we said Q is the horizontal asymptote. The value of Q, it was 1. then the graph is going to say 1 to positive infinity. So it's going to be somewhere here. It's going to be 1. And then we're going to have what? That broken line that will act as what? As asymptote, right? So that is the range for that question. All right. Thank you very much for being with me on this interesting lesson. This is my last word for you, my dear learners. That says our greatest weakness lies in giving up. The most certain way to succeed is always to try. Just one more time. Thank you very much.